Thank you. Good morning to everybody. I'm from two departments, one at the Faculty of Mechanical Engineering and one in the CIIRC, in the Department of Production and Automation. So I should like to explore our investigation of a concept of physically interconnected robots, what they could offer as a new property. So the presentation is starting with the concepts and describing some basic contribution from the mechanical point of view, and then some examples of application. So physically interacted robots means that you have one active, another active, and they are really interconnected by their grippers. But this can be extended to have two actives that are interconnected by some passive device between them, or to have an active robot and it is connected to the environment by a passive device. All of these have some advantages and interesting properties. So from the mechanical point of view, there are benefits of the physically interconnected robots by what I called finally Volt principle from the medieval CIIRC, increase of stiffness, eigenfrequency, and accuracy by connecting them. Then if they are connected, they have more sensors than is necessary for the degrees of freedom, and this enables self-calibration or improvement calibration procedures. And finally, you can see the improved workspace and some manipulation problems can be solved. So what principle? We started to connect two robots for doing a machining, and we were surprised that by connecting, we achieved the increase of stiffness by 3.5 times and not only 2 times. So if you connect the robots that are perfectly parallel, then you obtain only twice the increase. But if they are in opposite, building a vault, then you can achieve finally exactly the principle from the Rome bridges or from the CIIRC, the vault principle, and increase the stiffness 3.5 times. But we added some additional measurement inside, and finally we really achieved in laboratory conditions measured 25 times increase of the stiffness, so going from 0.5 Newton per micron to such medium size KUKA robots to 12 Newton per micron. What is really a machine tool, and we can think that based on that we might be on a path to replace really the traditional machine tools by physically interconnected robots, because the stiffness, eigenfrequencies, all of that can be achieved. It can be extended by a concept of mechatronic stiffness that is auxiliary structure. In fact, the stiffness can be even more improved and so on. Self-calibration. If you have a kinematic loop, like here it is maybe the simplest one degree of freedom, very simple. You have two measuring positions, the translation S and the angle phi. And if you can measure both, you can, without any additional knowledge, just from these measures to get the whole dimensions of this device, and this is called self-calibration. So you start with a completely unknown dimensions, just having additional redundant sensors, and based on online measurement, you can identify all the dimensions. This is in fact something like a principle of redundant measurement. In physics, you usually repeat the measurement of some length on left-hand side many times and do statistics. Now in mechatronics, I can afford to have multiple sensors and in one real-time instant to measure the dimensions. And based on that, you can do the statistic online, or you have even additional effects that are increasing and improving the capability. So we applied that to some different machines. where this self-calibration or improved calibration was used, especially the upper, there is called REDCAM, redundant calibration and measuring machine, achieve very interesting properties. If this machine is measuring 6 degrees of freedom in space, you achieve here this is the uncertainty of one sensor, and it is demonstrating the addition of the errors. If you have a multiple redundant measurement, then you achieve no adding of the errors, and you achieve the same accuracy as one single sensor, even there are 9 sensors. This has been extended to optical way, and for such a machine, here is upper is a laser tracker that is of size of me, and you see that it is here on the machine upper, so the machine is of size of this room, and there was a measuring by delivered laser tracker improved from 7 times from 0.07 to 0.01. Concept of redundant calibration in general. But these connected robots can lead to concepts that you have machines that are not interacting with the ground more than just static reaction, just gravity. All dynamic forces that are going to frame, and everybody knows from machine tools that the most difficult problem is to have a good frame. You can avoid this problem completely by the floating principle. Here is described that in 6 degrees of freedom it's possible, and moreover the concept we are calling motor on motor, so intermediate mass in your drives could accumulate and restore back the energy from the inertia mass. If you replace that by cables, again a machine tool of such size of this room has about very low frequency, very low stiffness, and the vibration would be of such size. If you add cables, you can immediately improve that incredibly 10 times, 20 times, very simply. So this is the redundant measurement, and in fact the mechatronic stiffness as auxiliary structure. How this physical interconnected robots can contribute to improve workspace and manipulation problems. So if you have a limited space, you can where you can enter, however, from multiple sides, you can get there by single robots, and at the working position to connect them and to achieve the same effect of the connecting robots for increased stiffness. The same you can do in extensive spaces where for example, is proposed to have such huge machines. Instead of that, you can have several smaller machines that are going to the desired place. They're connecting, and by the connection, achieving the same force and stiffness capability as the large one. Certainly, you can have a multiple of them, not only 2. The same can be used as well for achieving have cable-driven robots without having cables in workspace. So, in fact, if you connect 2 cable-driven robots, you can achieve that this workspace is completely free of the cable. So it can be manipulated there by the cable-driven robots without any collisions with the driving cables. Then another effect that I have been encountered with is how to enable to use cooperative robots for manipulation of heavy objects. The idea is that you can use a passive devices that were sometimes also developed as a jigs for human beings to improve, make their work simpler and lighter. And the same can be used for robots that are enough small, enough low force that cannot injure the workers, and this can be used for manipulation by interconnecting them in the cooperation with human or side of the human. The same can be used for manipulation of flexible object, because for manipulation of flexible object usually there is a prepared jig that is keeping the flexible object in a desired shape. But if you use a multiple robots, you can replace that without this jig that is heavy and requiring very strong, very powerful robot. And finally, the problem how to get assembly of cables in cars, or generally how to do the sewing through some holes, can be solved, in my point of view, only by combining robots, because there must be one robot pushing through and one robot taking that out of the hole. And if you combine them, then you can achieve the solution of that is peculiar how to manipulate such flexible objects. Conclusion is simple. I am convinced that physical connection of robots brings multiple and different benefits, and on our side the research is ongoing. Thank you very much for your attention.